Hello big data people, welcome to this video. This video is about the tutorial of Kafka. So we are going to see about the Kafka architecture. We are going to see about the Kafka architecture in a detailed manner. Kafka architecture includes of concepts like topics, partitions, producers, consumers, etc. To design the Apache Kafka architecture, we need the essential parts which are explained in the later slides. Data ecosystem. So several applications uses Apache Kafka forms an ecosystem. So this ecosystem is built for data processing. So it will take inputs in the form of applications that creates data, and outputs are defined in the form of metrics, reports, etc. So we have a below diagram which will explain it in a better manner. Kafka cluster. So a cluster is a system that comprises of different brokers, topics, and their respective partitions. So data are written into the topic within the cluster and read by the cluster itself. And producer sends writes data messages to the topics within the cluster. In order to store a huge amount of data, different producers within the applications send data to the Kafka cluster. Consumers. So consumers are the one who reads or consumes the messages from the Kafka cluster. So there can be several consumers consuming different types of data from the cluster. So the beauty of Kafka is that each consumer knows from where it needs to consume the data. And brokers or server. Kafka server is known as broker. So broker is a bridge between producers and consumers. If a producer wishes to write data to the cluster, it is sent to the Kafka server. All the brokers live within a Kafka cluster itself can use that one. Also, we can have multiple brokers too. Topics. So we are speaking about this earlier also. So it is a common name or a heading. So given to the represent similar types of data. So in Apache Kafka, there can be multiple topics in a cluster. So each topic specifies different types of messages. And we have partitions. So partitions are data or messages divided into small subparts known as partitions. So each partition carries data within it having an offset value. The data is always written in a sequential manner. So we can have infinite number of partitions with infinite offset values. So however, it is not guaranteed that to which partition the messages will be written. Zookeeper. So this is not part of Kafka, but Zookeeper is a separate application which always works with Kafka. So a Zookeeper is used to store information about the Kafka cluster and details of the consumer details. So it manages brokers by maintaining a list of them. So a zookeeper is responsible for choosing a leader for the partitions. If any changes like a broker dies or new topics arises, etc., the zookeeper sends notification to Apache Kafka. So a zookeeper is designed to operate with an odd number of Kafka servers. Zookeeper has a lead server that handles all the writes, and rest of the servers are the followers who handle all the reads. So every user does not directly interact with the zookeeper. That is the main point here. But via brokers, we can communicate with the zookeeper. So no Kafka server can run without a zookeeper server. It is mandatory to run the zookeeper server. This is the first diagram we are going to see. This is Kafka architecture. So we have zookeeper. Okay, we have zookeeper server 1, zookeeper server 2, and zookeeper server 3. The first server 1 is the follower, second one is a leader, and third one is a follower. So the first one will communicate with the Kafka broker 1 and Kafka broker 2. Second server, the leader can follow with the broker 3 and broker 4. And server 3, zookeeper server 3 will communicate with the Kafka broker 5. But all the zookeepers, server 1, server 2, server 3, all have communications between them. The brokers have separate communication with the zookeepers, and the zookeeper servers will have internal communications between them. It have both way communication. So any question arises, any topics, any messages, any data is passed, everything will be passed to the leader. So this is zookeeper server 2 here. So it will be passed to the leader first, and then the instructions will be followed to the followers here. So note that Kafka version 0.10 and above, a zookeeper does not store the consumer offset value. It is stored in the Kafka topics itself. Okay, so the above figure is explained here. So there are three zookeeper servers, where server 2 is the leader and the other two are the chosen as its followers. The 5 brokers are connected to these servers. Automatically, the Kafka cluster will come to know when brokers are down, more topics are added. Hence, on combining all the necessities, a Kafka cluster architecture is designed. This is the Kafka architecture. So we have a producer and we have a consumer. So the producer is writing a message and the consumer consuming a message. Okay. So we have the zookeeper at the bottom. So it will be getting the Kafka broker ID from the producer and updates its offset value to the consumer. So in the Kafka class ecosystem, all these three things present. One is Kafka cluster, brokers, and zookeeper is present. Okay, the Kafka cluster is again being partitioned into many brokers. So we have two brokers here, broker 1 and broker 2. And inside this broker, we have topics and partitions. So there is one topic called topic A, and there is one partition called partition A. And the broker 2 has topic N, and partition is N minus 1. Okay, N minus N. So there are multiple partitions present in a single topic, and these topics are present inside the broker, and the messages are consumed from the producer, which is having the messages are large messages are partitioned, and all those informations are updated in the topics, and these brokers will be storing all this information given to the consumer for consuming. We have a zookeeper in order to get a broker ID, and according to the broker ID, the broker as consumed to that particular consumer based on the IDs. Okay, thanks for watching the video. Big Data Tunnel, be Biggie. Please like, comment, share, and subscribe. Big Data Tunnel.